Hey everybody, welcome back to another video. And in today's video, we're going to be talking about the problem House Robber 2. Now, if you haven't seen my previous video on the first House Robber problem, then I suggest you check that out first. But regardless, this problem is actually very similar to the first one. In fact, the setup for it is almost exactly the same. And your job is basically to rob houses on a street. So looking down here, we have an array, which is basically our list of houses. If you rob one house, then you cannot rob the house next to it because then that would set off an alarm. So then you would have to rob this one. The thing is, that's how the first problem works. Because in the first problem, the houses were in a list like this. But for this problem, the houses are arranged in a circle. And so that actually changes things. So you can think of the houses being arranged like this. So the 2 is next to the 3, 3 is next to the 2, and then this 2 is next to the 2. And so in the previous problem, if you rob the first one, then you would have to skip the second one and then rob the one after that. Or you can skip the first house and then rob the second one, but then you wouldn't be able to rob the last one. In this variation of the problem, since the houses are arranged in a circle, if you rob the first house, then you cannot rob the last one. Because again, if you look over here, if we rob this house, skipped this one, and then rob this one, these houses are still technically next to each other. So then that would set off an alarm, thus breaking the constraint of the problem. Now, just like the first problem, we can still leverage dynamic programming to solve it. Now, the solution to this problem is actually very similar to the first one. So let me show you how. So I'm just going to give a brief overview of how we solved the first house robber problem. But again, this is just going to be an overview. If you want to actually know how the house robber problem works, then go watch the first one so you can get a more in-depth explanation. Because since the houses were arranged on a street, if we robbed this one, then we couldn't rob that one. And so let's say we decide to rob the first house. The maximum value we can get here is 2. But by robbing this house, we forego this house. So then this one would get skipped. And then finally, we can rob this house. So the maximum value that we have so far is 2 plus whatever we rob here. And so 2 plus 2 is 4. Alternatively, we can choose to skip this house and rob this one instead. So let's say we skip the first house and we opt to rob the second house, then we're left with a value of 3. But then of course we can't rob the last house either. So if we take this path of skipping the first house and robbing the second one, then we're left with a max value of 3. The previous option we took by robbing the first house, skipping the second one, and then robbing the third one yielded more profit. And so that would be the optimal solution to that problem. And so in that case, it would be more optimal to rob the first house and the last one while skipping the second one, versus what we have here. And the beauty of this problem is that we can basically apply this logic to the House Robber 2 problem. And so the reason dynamic programming works so well for this problem is because we can choose and compare which paths we want to take, and then ultimately determine what is the max value we can get by making certain choices. Now, again, I'm not going to get into it because in the last video, I drew a recursion tree explaining all the different choices we can make. The House Robber problem, and by extension, the House Robber 2 problem, basically boils down to the choices we make. The only difference being is that the House Robber 2 problem adds a little constraint where the houses are arranged in a circle, so technically, the first house is also next to the last one. But if we just change the way we think about the problem, we can then begin to see how the logic from the first House Robber problem can be used to solve House Robber 2. Alright, so now using the logic from House Robber 1, how can we use this to solve House Robber 2? And so first things first, let me add a visual aid. Remember, the way this problem is laid out is in a circle. So the houses are going to look like this. So remember, if we rob the first house, then we can't rob the last one because they're right next to each other. And because this is true no matter how big the input gets, we know that the problem at this point can break down into 2 cases. One where we rob houses from the first house up to the second to last house, which in this case is here, or another case where we skip the first house and rob houses starting from the second house all the way to the last. And so if we reflect this up onto this array right here, we can see that the problem basically splits into 2 ranges. Because remember, in the first case, we can choose to rob the first house and all the houses in this range up until the last house. Or we can choose to skip the first house and rob all houses starting from the second house all the way to the last. And so again, this produces two different ranges. And basically, if we apply the same house robber 1 logic to both of these ranges, then all we have to do is just calculate the maximum that we can get in either range, and then that'll be our final answer. And so in the case of house robber 2, the maximum amount that we can rob is 3. Because if we choose to rob the first house, we net 2, but then we skip the second house. Alternatively, we can skip house 1 altogether and rob the second house, which nets us 3, but then of course we have to skip this one, leaving us with our final answer of 3. Alright, so hopefully that's all making sense. Again, house robber 2 is pretty much the same problem as house robber 1, the only difference being the houses are arranged in a circle, so the problem really just breaks down into two different ranges. We either rob the first house all the way up until the second last house, or we skip the first house starting from the second all the way to the last house. And one of the beauties of this problem is that we can essentially abstract the logic we use in house robber 1 into a helper function. And so using that helper function, we can call it on both of these ranges, and then at the end we just compare which one produces the maximum value, and then we return that, thus giving us our final answer. So hopefully all of this is making sense. Now let's jump into the code. Okay, so first things first, we're going to start off with some edge cases. So if for whatever reason nums is empty, we can just say if not nums, return 0. And then additionally, in the case that our nums array only has a length of 1, then we can just return whatever value is at index 0. So if length of nums is equal to 1, we just return num 0. So pretty straightforward, just a couple checks we can make to let us exit early so we don't perform unnecessary logic. So the main bulk of the problem is going to be this helper function. And remember, this helper function is going to be robbing a range of houses. And remember, this range is where we either rob the first house and all subsequent houses up until the last one, or we skip the first house starting with the second house and rob until we get to the last house. So because of that, we need to have a start and an end point. And so we can declare a function called def rob range because we're robbing a range of houses. And we need a start and an end point, so start and end. So far, pretty simple. And then we need to initialize variables. These variables will keep a running total of the maximum amount of money robbed by either considering robbing the first house or the previous house. So we'll just call those rob cur and rob prev. So of course, those will be set to 0 at first. So the next thing we need to do is iterate through our range. And so for this, we can just iterate through the entire list of houses. And then depending on what we input in these parameters right here, will essentially allow us to constrain the problem between the two different ranges, either skipping the first house and robbing the last one, or robbing the first house and not robbing the last one. So now the next thing we need to do is rob the range of houses. And so this will depend on whatever we put in the start and end parameters, but the flexibility that gives us allows us to rob different ranges, which is what we want to do, because we've already established that there's two ranges we have to concern ourselves with for this problem. So I'll just simply be for I in range start end plus 1. And the reason why we put plus 1 here is because in Python, range is exclusive of the last value. And because arrays are 0 indexed, we just add the 1 here to offset that. All right, so now pretty much what we do is update our rob cur and pre values while we're iterating. And so basically here, we just want to calculate the maximum amount of money that can be robbed if the current house is robbed. And of course here we compare it with either we take the value if we rob the current house or the max value of robbing the previous house, and then we compare the two and make our decision from there. So it'll just be rob cur and rob prev equals the max of nums I plus rob prev, or rob cur. And then rob prev gets updated to whatever rob cur is. So basically what this is saying is rob cur gets updated to the max of nums 1, so the current index plus the previous value, or the current value that we're looking at. So whatever the maximum value is between the two will then be updated into Rob Kerr, and then what Rob Kerr was previously will be updated to Rob Preve. So then at each stage of the iteration we have the most up-to-date calculations. And then after this, all we have to do is just return Rob Kerr. And so the last thing we need to do is actually make use of this helper function. So we can just return the max of robbing either of the two ranges. And so the first range is going to be rob range from 0 to the length of nums minus 2. And then rob range from the second house, so the index of 1, up to the length of nums minus 1. So this range is going to be, if we decide to rob the first house, all the way up to the second last house, or starting from the second house, going all the way up to the last house in the list. And then again, after robbing these two ranges of houses, we calculate the max between the two, and then that's how we get our final answer. So that's going to do it for this problem. Hope everything makes sense, and I'll see you guys in the next one.